All right, so let's think about adding fractions using some different strategies. So one is to just keep them whole numbers with the base 8 units off to the side. So again, we could line them up, and so we have 2 3/4 and 1 7/8. But again, you can't add these because right now we have 2 whole pizzas, so I'll draw the picture too. So I have 2 3/4, so here's my 2 pizzas, and I have 3/4 of another one. And same size pizzas, just cut differently. So I have 1, and then I'm going to cut, and cut, because that one's cut in 7/8. So the shaded part is what I have. So here I have this. Okay. So, and this is kind of actually another strategy. So, but I'm going to try to correlate the two together. So this is kind of like a base 10 picture. It's just a pizza picture to help us out. So first of all, one slice of, let's see, one slice of this pizza does not equal one slice here, right? This is, if I'm hungry and I only get one slice of pizza, please give it from this pizza, not this one. These are little. But if we're going to add the slices with slices, you know, we need to have them be the same because you can't add apples and oranges. So you need the same size to be able to add. So I am going to basically cut these, and when when you get a common denominator, what you're doing is you're converting it to something that's equivalent. And so there's my 1 7/8. I only had to cut this one. 8s work with 4s, so I didn't have to use something bigger like 16. So times 2 and times 2. And again, why do I multiply by 2? Is because I'm going to cut each of these slices in half. And when you cut something in half, you're making something that used to only be worth 1 to now be worth 2. So each like big slice is now going to be cut into 2 little slices, which means what used to be 3 is going to become 6. All right, so that's kind of the conversion there. And then what I'm going to do is I'm going to add my fractions with fractions, whole numbers with whole numbers. So 6 and 7 gives me 13. And again, you can still use those strategies that we had from adding, like for example, 6 and 7, like making, you know, breaking that apart into like a doubles plus 1. So like those ideas don't go away when adding the numerators, like 6 and 6 make 12, add 1 is 13, and then 8s, and then I have my 3. And then again, I can't have an improper fraction in a mixed number. I need to kind of stick with all one method. So if I have 8, I have enough to make another whole. And then in base 8, if I have 13 objects and I'm in base 8, I would use 8 of them to make the new one, and I'd have 5 left over. So it would look like that. Now, if I'm just only doing it with a picture, so I have 2 3/4 and 1 7/8, I got my common denominator, so I have this. The way that a kid could add on this one is they could try to fill in the holes. So what you could do is you're like, okay, well, I have these 6 slices up here, so I am just going to take one of these slices and I am going to put it right in there. So I'm just going to move one of these slices. Oops, sorry, it's too wet. And I'm going to move this slice and put it in there. So that's going to make a whole pizza. So then you can kind of see there's your 4 whole pizzas using your picture. And then now, how many do I have left? 1, 2, 3, 4, 5 that are shaded. So 5. And what unit are you in? 8. So the 4 are your whole pizzas. The 5 are the slices that are not regrouped. And again, I have one here, and there, and there, and there. So those are the 5. And the 8 is your unit, like the pizzas are cut in 8s. So this is kind of a picture model of doing it with pizzas. This is how you do it with keeping them in mixed numbers. And again, they're obviously related to each other. All right. Another way to do it is to use improper fractions, because then what you're doing is you're converting everything to slices. And again, I'll try to correlate that to your picture. So again, you still get your common denominator. You can either do it before or after, doesn't matter. So I'm going to make this improper. So the way I started out my problem is I had 2 whole pizzas and then 3/4 of another one. So again, 2 times 4 represents the two groups of 4 pizzas, because 2 times 4 is 8. And then the 3 extra are 9, 10, 11. So again, that's why when you do improper, you take 2 times 4 because you have 2 sets of 4 and then add in the extras. Same thing down here. I have 1 whole pizza. Excuse me. And then the other one, and again, these should be the same size, but not super good at drawing today. All right, and then that's what's shaded there. So again, if I cut this guy into 8s, that's what happens when you make it into improper. You're actually cutting it. So again, this 1 is going to have 8 in it, plus these over here, that makes 15, and the size is 8. Now notice these are not the same size slices, so I still have to get my common denominator, so times 2, which is 22/8. And again, when you're getting an equivalent fraction, what that indicates is the reason I multiply by 2 is because I'm cutting all these in half. And when you cut them in half, what used to be 1 slice is now 2. So each big slice is worth 2 little slices. And so that's why I multiply by 2. So instead of having 11 big slices, I now have 22 little slices. All right, so now I have slices with slices, and everything is in base 8 here. So I don't have that whole number part. So if I add those, I get 37 slices in 8. And again, if you want to count them, oh, I need to cut this guy too, sorry. All right, if you want to count them, you know, there should be 22 and 15 and then 37 total. All right, so then at this point, now I want to go back. I've cut them in all these slices, and now I'm like, okay, now I want to put them in pizza boxes, right? Like, so I'm kind of like, well, if I put 8 in this pizza box, 8 slices there, 8 slices there, 8 slices there, 8 times 4 is 32. So 8, when I divide into that, 8 goes into 37 4 times. That means I can make 4, if I have 37 loose slices, which is kind of what that means. Like I have 37 loose slices. It's like if I pulled these all apart, then if I start to package them in boxes, I can put 8, you know, in a box, 8, 8, and 8 to make a whole pizza. And then when I do that, 4 groups of 8 use up 32 slices. Again, we're in base 5, or base 8, sorry. There'd be 5 left, and then I would have 8 left over. So if you have 37 in base 8, you'd have to group it, right, you know, into 4 sets of 8 and then 5 left over. And again, this is, the whole number part is base 10, like, you know, as far as like 24, 34, 56, you know, that's fine out here. But the leftovers have to be in sets of 8. So I have less than 8, that's good. And so I get the same answer. It's just here I'm focusing on 1 unit, slices. Here I'm focusing on 2 units, pizzas and slices. But you should get the same answer either way. All right, and again, this is a visual model for doing that. Some other ways of doing this adding problem would be using some of the strategies that we used before, like rounding up with compensation, decomposition, things like that. So for example, I might break this into, say, 2, and then I might break this into a common denominator of 6/8. So it's still 3/4, I just scaled it to 6/8. And then I might break this into a 1, and instead of 7/8, I might break that into 2/8, because that's super friendly with that 6/8, and an extra 5/8. So I'm breaking my 2 and my this, I'm just rewriting it. So that's just breaking it in half, not a big deal. Common denominator times 2 times 2. And then I'm breaking my 1 by itself. And then the 7/8 I'm breaking into 2/8 and 5/8. And the reason I did that is because 2/8 and 6/8 are super friendly numbers, right? They make a whole, like, so together, these two make a 1. And so then do you see I have 2, 3, 4, and 5/8. All right, and so that's pretty slick. The other thing I could maybe do on that one is, let's see, what else could I do? 2 3/4, that's probably the most popular, is I could maybe do, what did I break there? I mean, I could always break the other guy for an 1/8, but let's see, what else could I do? I could round. Let's do that. So if I do 2 3/4 plus, and just round up to 2, that would be 4 3/4. But then notice I need to subtract what? I need to subtract an 1/8 because I added too much. And so I need to subtract an 1/8. And some of you might be like, that's not a lot easier, but it's not bad. Get a common denominator times 2 times 2, 6/8. You don't have to ungroup or anything. And then, and then subtract an 1/8. And you get 4 5/8. So, I mean, not bad, okay? So you can use some of those strategies we used earlier, like rounding with compensation, or decomposition is probably the most popular to use with fractions, to help you get other strategies to get the right answer. All right, I'm going to end it there. If you need more help, let me know.